It can't see. I don't even have the camera connected. The camera is right there, unplugged.
Also, everything we've ever watched has been like recorded in the past in class.
No, this is the first year I've been doing it this way.
Oh, so cool. So very cool.
It is way less time consuming. Okay. So, well, there's nothing connected. We're wasting time we don't even have. So here we go. This meeting is being recorded and I'm talking. So all that was recorded. Here we go. What I've done, and by the way, I'm not an idiot, that is not being projected. So don't think you're going to go home and read every single test question because, well, good. Because we're on this computer that you're seeing that right now. All right, so what I did, anything that I highlighted red, I went over the past 3 years of test scans, and I put anything that kids scored lower than 70% on, I put it red. So notice at the start, most everything's black, and you're doing just fine. Then you get 2 questions. We went over them yesterday. Remember, don't answer what temperature something is with a letter. Remember that? And then we talked about the other one yesterday. Then 21, 22, 23 are typically low. And then the entire rest of the test is typically very low. So all I did today was make a presentation that will help us do better on every single question on there that's red. Okay? So that's the goal. My goal is to maintain our 100% average. How cool would that be if everybody got 100% on their test? Now, it won't happen because Tanner's not here, so he'll fail. And anyone else. Not really. I could tell Tanner's family that this is online and he could review, or Ryan could, or we could just realize Tanner's a genius, so he probably doesn't need to anyway. Fair enough. All right, so here we go. I want to first talk about how to read a graph. So I have this little lesson I just drew up called How to Read a Graph 101. Reading a graph is a skill that has left most everybody. And I kind of think it's because you never look at maps anymore. Who has ever even touched a map made out of paper? Raise your hands. Okay. How many of you think you adequately know how to use a map made out of paper? Okay. It used to be every human on the planet knew how to use a map made out of paper because that's how you found your way places. Now, yeah, you just talk to your phone and it talks back. All right? I will tell you in San Diego, I wanted to go to Rubio's and it sent me to a parking spot. It's not very good fish tacos. Okay? I had to go to Cheesecake Factory and I hate that place. Okay, moving on. But my wife loves it and I'm a good husband. Here we go. Whoops. So, how to read a graph 101. Shh. It's America. You can like Cheesecake Factory, but I cannot. We're fine. All right. We good? Okay, the first thing to do when you are going to read a graph, you need to look at the axes. Because if you don't know what is there, then you have no idea what it's talking about. The axes give you the information you need to process in order to solve the question. And sadly, you skipped right over that and you just look at grids. You're like, oh, I don't know what it is. Well, read it. Okay, number 2. Shh. It seems obvious, but people don't do it. You need to read the question that is being asked about the graph. It will give you information. It gives you lots of information. And if you just think about them, generally you can answer these types of questions every time. So number 3, find the point it is describing, meaning the question. All right? A graph, I'm going to get rid of all this. A graph is just a grid system. That's what that picture was. Okay? It's just setting up a grid like a map, north, south, east, and west. All right? You will be given coordinates. And guess what lives at those coordinates most of the time? The answer, or at least something that will help you to get the answer. All right? Then, number 4, if it isn't just plain out the answer, you have to use your problem-solving skills and your understanding of the English language to answer the question. Okay, so read axes, read question, find the point it describes, and then try and reason your way through the problem. This skill will help you do better on the ACT. Did you know you have to take exactly 0 science to do well on the ACT? There is no biology, there's no chemistry, there's no physics, there's no anything. There's just problem solving based on graphs and reading. Okay? It's really the second reading section of the ACT. It has nothing to do with science. Besides, it's sort of sciencey looking. Okay, here you go. Next, I want you to answer these questions. I'm going to get these out of the way because they will confuse you. All right, so this is how I want this process to work. I want you to try and answer every single question that's on these slides. Why am I asking them? Because I'm trying to give you the tools so you can answer the test, but they're just me. When a teacher told me they were going to review for a test, that's one of the only times I paid attention. There is nothing today that doesn't directly relate to a question. Well, if you don't know, we'll go over it. But think about your knowledge of the English language and maybe some problem-solving skills. And I don't expect you to just figure them out. But a handful of you will be able to figure out whether it's saturated, supersaturated, or unsaturated. Like I'm pretty sure Dylan's got it. I bet Rhino has it. I hate when I have more faith in someone than they have of themselves. Bauer. Okay. Does it bug you that I never say your first name? Okay, good. Because I'm never going to. Okay, if you haven't talked to your lab partner yet, start doing it. See if the 2 or 3 of you can figure it out with your combined brain power. Okay, 10 seconds. Here we go. Okay. How many, is there anyone that thinks they got all 3 of them right? Maybe. Is there anyone that thinks they got all 3 of them wrong? A couple of you? I doubt you did. Thank you. I don't know if I dare do this, but I'm going to try again. There you go, Zach. You're welcome. Oh, There's no way I get this far. Wherever this lands, eventually pass it to Rachel. And Aubrey, you ready? Uh-oh, she is definitely too close. I will hand deliver this one. I don't want to poke out your other eye. I had a bad experience. Is that your pen? Aubrey, is this yours? Okay. All right, here we go. Whew, so much pressure, right, Ryan? Okay, number one, please follow this logic because all three of these questions are exactly like questions on the test. Exactly like them. So here we go. First, if NaNO3, so, well, I guess I better follow my own instructions. Look at what the thing's talking about. Solubility per 100 grams. If you didn't notice the 100, you're going to be in trouble later. All right? Versus temperature. So what this
the white team was throwing, they were trying to pass the ball.
That I ask this 3 different ways? Here are the 3 different ways. They're listed almost in order. 1 is a matching term. The definition of saturated is a solution that holds exactly the amount it can at a certain temperature. Okay? Another one is using this definition. Actually, this is on there twice. We know it is saturated when there is excess at the bottom that is undissolved. Do you remember that yesterday? So this is our Cheerios. All right, we have our milk, but we have sugar at the bottom. Listen to me right now. The words that I'm saying are super important. If there's anything then we don't actually know for sure that it's holding as much as it can. You would if the data point, like this red line right here, is on the line for the thing we're talking about. So if it said 200 grams of sugar in 220 degrees water, that would be exactly saturated because it's exactly on the line. Are we okay with those 3 different ways to look at the exact same thing? Speak.
When it's talking about the temperature, it means the temperature of the water, right? Or the...
You're still going to get 100% on this test. You're smarter than the person that already got 100% of this test. All right. A lot of you were squinting. Is that going to help? Did that brightness help? Tons of people are either blind in this class, or that was too bright, or they're Jeremy Shaw. You are fun to make fun of because you have the same smile on your face no matter what. That's why we love you. Okay, moving on. Unsaturated. Ignore this thing right here. Unsaturated means it's not holding as much as it can. This is what I mean by your knowledge of the English language. Un means not as much. Okay? So we have the definition. It's a solution that's not holding as much as it can at a certain temperature. Then our next one, we know it's saturated if there is not excess stuff on the bottom that is undissolved. Okay? If the liquid is just crystal clear with nothing, now it could be colored, but if there's no stuff at the bottom, then it is unsaturated.
So that's a type.
Yeah, yours put unsaturated.
What did I put?
No, it is saturated.
Oh, thank you. Sorry. Yes, no one all day has said that. That was a big mistake.
I was hoping they knew what you were talking about.
We'll assume they did. The problem is these were just cut and pasted, and then I just changed a few words, so obviously that one I forgot. All right. So we know it is unsaturated, I mean, if there is not excess on the bottom undissolved.
How do we know that for sure though?
It will tell you.
Okay.
It will say like there is nothing besides the water. Like you'll see it on the next slide, well, in 2 slides. Okay, so check mark, that's your definition. Next, that's another way to know that it is unsaturated. And then the third way is if your dot is under the line it's referring to. So if it says your temperature is 20 degrees and it's holding 180 of sugar, this happened yesterday too, it cannot stop now, then that dot would be below the line you were talking about. So you would say it's holding less or it is unsaturated. What do you need? I have 1 fat marker.
You have 1 fat marker.
This is a doozy. I won't throw it to you. You have a broken hand.
Oh, I thought I made
Did she break her other finger? That sounded painful. Best breaking arm story ever.
And that what story would be?
She broke her arm giving 5s to other people.
How?
They were doing like a up high, down low, and she was going up and someone was coming low. Annie's elbow. Boom. Achy, breaky arm. Well, it does sound impossible, but who's ever taken an elbow to the arm? It does hurt. Every basketball game you ever played in. It turns out I took a skateboard wheel to the arm today in the hall. That hurt. I was walking and a kid turned and just jacked me. So I cut him. That was on tape. I didn't really. Okay, moving on.
Abby, that's how she broke it. She said in like seminary that like someone like landed on her hand.
Yeah. Annie's elbow landed on her arm and broke
Came
it.
down on her head.
Yeah, so they were given 5s, and Annie was on her way down, and Abby was on her way up, and Abby's like Annie's razor sharp elbow broke.
She said she broke like right.
Oh, it might be there. I don't know where it is.
She thought I had some meat bones.
More milk. Drink more milk.
I've been way harder than that. No.
Well, nothing against either one of you, but you look way different than Abby. Okay? Slightly. Anyway, moving on.
We're not talking about powder. They are still bones.
Well, they are. This thing is dumb. It's not working very well, but here we go. Okay, are we okay that the dot would be under the line? Okay, then the third one is a little confusing, but actually on the test is extremely simple. Okay, super saturated. Almost blew that one, didn't I? Give it all away.
More.
No.
Is it then more?
Gosh dang. Just quit guessing. Shaw, I'm trying to highlight it.
You're trying. It's okay. I can read it. It's a little hard. Thanks, David.
Okay, quit guessing. Just don't be dumb. Relax. I will explain it, and you will waste less effort and my time. All 3 of these are said this way to help you answer 3 questions. Oh, there's a misprint there too. More than it can. No. If it was super saturated, I could go with my salt right here, pour a little bit in the lake, and it would turn to a solid. It would be really, really amazing. What?
Like the Great Salt Lake, you can literally like walk on it.
It's because it's not very deep.
No, it's like you don't have to move to float, or you just sit like in a lawn chair.
Okay, well, I was just there this summer. You are right. But it's not super saturated.
Oh, okay.
It's not even saturated. All right. Here we go. Super saturated. As soon as I touch this, it's going to go back to how it was, though, Jeremy. Super saturated. The key is that the substance turns to a solid once you disturb it. I'm going to take a risk here and hope that it works better when I reset it. Okay, so listen. A saturated solution, you have to heat it, dissolve stuff in it, and then let it cool. But you can't touch it. You can't put more stuff in it. You can't even wiggle the pot or it'll go to a solid. I have a video example of this.
Yeah, like what's an example of super saturated?
I'm ready for it to reload. Does anyone see me trying to push that button?
Yeah.
Okay. There we go. Okay, look. Shh. It's already passed. Okay, watch. This is a liquid. I add a little bit of crystals, and the solution immediately turns to a solid. All of it.
Are you gonna dump it out?
I couldn't dump it out. It's like a rock in there.
Why does it do that?
Well, you can read. All right. This is listen, it's a supersaturated solution of sodium sulfate. And it's crazy. Like, you wouldn't believe me, but there's only like that much water in it. But you get that water really hot and keep adding sodium sulfate. It will all dissolve because you're heating the water really hot. But then, once you have it all dissolved, you turn your heat source off and you don't disturb the thing at all. Because I could get the same results if I just came up and I hit that thing. That would be enough that the solution says, oh wait, I can't hold this much. And it goes to the solid, right back to it. So the key is that it had to be heated, but specifically that it turns to a solid when you disturb it. You with me? If it turns solid, the answer is supersaturated. All right. Now, what's kind of cool about this life, this world, I should say, we had to heat this to get this to happen, right?
Did you do this?
So what? Yeah, this is me. When you reverse it, heat comes out. And your hand warmers that you can reuse by boiling and then waiting and then pushing the little snappy button. Anyone have those? This is the exact same thing. You heat it and put energy into it to dissolve the thing. And then when you want the heat, you snap the little button. That's your disturbance. And it starts to solidify again and releases the heat that you put into it hours ago. And it's a pretty, really sciencey, nerdy way to keep your hands warm. And I'm getting a little bit aggravated right here.
So it just holds in the heat from when you boiled it?
Mm-hmm. You put energy in.
Oh, okay.
It's not like I'm going to keep this heat, but it took energy to break it apart. You're going to get the energy back out when it comes back together.
That's so cool. I thought it was magic.
That too. Okay. Quickly read through these and see if you can answer these 3 questions. Bonneville sophomores are going to get rocked. There's only 2 of them. Okay, discuss for 30 seconds. Okay, 5, 4, 3, 2, 1. Here we go. All right. Oh, come on, for heaven's sakes. What's the key word to number 1? Turns to a solid, which means this was supersaturated. All right, number 2, most missed question on the whole test. You have a cup of tea at 35. It's clear and brown in color. The tea must be cooled to 10 before the sugar crystals begin to appear on the bottom of your teacup. At 35, the tea was? It's unsaturated. Good. So, shh. It's important to realize why you got it wrong. At 35, was there anything there? No, which means it was unsaturated. You had to cool it until something showed up. So, what would we call it if this question asked about 10 degrees? Then it would be saturated. All right. This, because it can. All right. This is just annoying me because the cursor's not showing up. So here we go. This one is what? It's saturated. The key thing there is that there is stuff at the bottom. Okay, next. Draw this, label it, write everything as fast as you can. Marky, you already did this, I think. Now, we already drew this once, but I've added things. I added them in parentheses. Good. Marky, why did I put those in parentheses? The under solvent. Why did I say the dissolving medium? It's the matching term. It's the matching term. It's important on this test to understand some things. Salt is your solute. Water is your solvent. You have to know that. But you need to know another layer than that. You need to know that the solute is also known as the substance being dissolved. What's this word right here say? Matching. These are the word-for-word things on your matching. Can you read that? The solute is the substance being dissolved. The solvent is the dissolving medium, or the thing it dissolves in. And together, these things form a solution. Okay, I got to move on in like 10 seconds because we got 12 minutes of stuff to do in 8 minutes of time. Who wants to stay after the bell? Okay, one person. I have to work anyway. Okay, here we go. Review your paragraph. What in the world do I mean by your paragraph? Oh, it's that thing that you better review because there's not a chance in Hades you remember it.
Oh yeah, I don't know that I have it.
It's on page 5 or 6, unless you never wrote it.
No, it's right there. Part of it.
Okay. 4 sentences. You never wrote it. Okay. I will say it, but I'm not going to say it slow enough for you to write down. So here. Okay, sweet. Not a video, just the audio. I'll have to suck in the whole time. Okay, good heavens, I'm not that good looking. I'm almost Carl, but not quite. All right, so here we go. The paragraph 4 sentence should say something like, the dissolving process is spontaneous. It's based on the kinetic theory of matter. And I'm going to say 5 sentences, but whatever. First off, the solute breaks apart because it's attracted to the solvent. Next, the solvent makes room. Finally, the solute moves in to that room. And then put a period because you'd be done. That's it. Sure. All right, next. Look, this is 8 points on a 30-question test. It's a huge question. Yeah. The solute breaks apart because it's attracted to the solvent. Okay, next. We're close. We have this slide and one more. This slide's pretty simple. I was so happy. Last hour, they rocked it. You will too. Never, you're not my dumb hour anymore. Fourth hour is. Hopefully. Okay, read through that quick as you can. Yeah.
I've scribbled this out like 5 different times. What breaks apart?
The solute always breaks apart.
So the solute breaks apart.
Well, I don't like your sentence at all.
Huh? These aren't sentences. These are just like.
Okay, it breaks apart. The solute makes room for the solvent.
And the solute is attracted to the solvent.
Mm-hmm.
So that is right.
Uh-huh.
And dissolve.
Sure. Good enough. Okay. GC stands for graduated cylinder. $30 more seconds. Every part of this question, this series of questions, it's just from the lab we did on the first day, and you're like, good, no doubt, this is not hard. It wasn't. We filled in a table that said 3 things about solid liquids and gases, right? This is from that. Here we go. Hopefully you get these. I know we're going fast, but we'll be all right. Oh, stupid thing. All right, which graduated cylinder contains the most water particles? A, or the cold one. Because the cold one's what? It's more dense. Okay, number 2. Which one contains the one with the fastest molecules? B, or the hot one. All right, next. Which graduated cylinder contains the liquid with the highest density? A is right.
Isn't water different though?
It's not ice yet. It's still the same until it turns to ice. Number 4. Which contains the liquid with the highest number of particles per milliliter? That is A, because, remember, I made you write this down. Density and number of particles in a milliliter were the exact same thing. Okay, next. Which one has the most room between particles? B. Who had them all right? Raise your hands. Okay, we're not done. Why are you packing up? I'm still giving you free answers to your test. All right. Saturation equilibrium. That word seems confusing, but we talked about it and you were all fine with it. Equilibrium meant change without really changing. So it means the point where some dissolves, but at the same time some will reform at the bottom. Okay? Saturation equilibrium, where some of it dissolves, but if it does, some has to go. And that was the dance party, right? Tatum knocks on the door, so we throw the nerd out the back. We have one in, but one has to go out. Are we all right with this? It's an easy question. It's just that you read the saturation equilibrium and you already checked out of reading that question. You're like, I'm done for someone magical. Okay, and finally, it's our last slide. No one loves these, but it's okay. Because there's only 2 of them on the test. 2. One of them, look at me. Actually, look right here. One of these is exactly word for word from the test. One of them. The other one is not very hard. So here we go. I will just do it because we're almost out of time. Remember, releases. Don't make any noise until that bell rings. If it releases heat, that means it has what sign? Negative. What's the most negative one? H2SO4. I hear noise. I shouldn't hear anything. It's still my time for 55 seconds. Which one will show the greatest decrease in solubility in hot water? It's the same answer. Look, the thing that's the most negative will decrease the most in hot water. Don't worry, that's not the one on your test. Next, what will happen to the temp of water when KClO3 is added to the water? Colder. Why? Because it's a positive number. It needs heat. Nothing gives off cold ever. Okay, listen. I have 5 seconds. If you don't study, your ability to remember is going to be going downhill. Your job tonight is to turn that around. Study, please.